Hello, ladies and gentlemen. Welcome today. It's Ms. Yurko here, and we are going to talk about multi-view sketching. Multi-view sketching is a way of looking at objects in multiple different viewpoints so you can understand how an object is built. We all pick things up and we look at them and we rotate them around and we can see them from different aspects, but sometimes we want to get measurements and other details that you can't get through a single point of view, particularly when looking at it as a sketch. So you're all pretty familiar with the idea of a concept sketch. This is a concept sketch of a computer mouse, and you can look at it and see it from above. We're looking at it from one view. We'll call this view the top view. It's looking at it straight down, and it's got shading to make it look more realistic. This is a concept sketch, and it helps you understand what a project is. We're looking at today is something called a multi-view orthographic sketch. So this sketch is also of a computer mouse. This is a multi-view. There's more than one view of the mouse. We can see the mouse from the top view, the front view, and the side view. This is called an orthographic sketch because we're looking at it straight on. We're looking at one view only, and we're imagining that we are looking at it from a parallel standpoint so that we are so far away from the object or so close to the object that the lines of projection are seemingly straight up and down right at your eye. When we look at orthographic sketches, there are 6 primary views that we look at. They are the top and the bottom, the front and the back, and the left and the right. Here is an example of a multi-view sketch that has all 6 named views, the top, the bottom, the front, the back, and the left and the right shown in one sketch. The sketch also includes a pictorial showing the object as it would be sitting on a table. This is also a form of parallel projection called isometric. When you combine these views together, you get what's called a multi-view sketch. You can utilize both orthographic views and pictorial views in the same sketch. These are all the same object. They're drawn on one sheet together, but drawn from different viewpoints. Now, several times in this demonstration, I've used the word orthographic projection. Orthographic is a straight-on form of projection. You're looking straight at the object. All your sight lines are parallel, and only one side of the object will be visible at a time. Looking back at our previous slide, you can see that when I'm looking at the top of the object in my pictorial view, I can see some of the top, some of the front, and some of the side. But when I look at it in my orthographic view, I'm only seeing it from the top. So these 2 top faces are shown, but none of the front and none of the side. Looking at the front view of the object, the 2 front faces are shown, but again, none of the side and none of the top. So these are orthographic views because they are straight on and showing only one side of the object at a time. That is orthographic projection. Where are we going to use this? Well, we're going to use this in our designs. We're going to design objects. We're going to come up with ideas for all kinds of things. Let's take a look at an example. This is my design for a robot ghost candy dispenser. A little something Halloween theme. Recently, we've been having concerns with diseases passing through the community, and we want to be able to have fun at Halloween without getting sick. So by reducing the contact of the people passing out candy with the trick-or-treaters, we reduce the chance of disease transmission. And we want to have fun with it. So I'm designing the robot ghost Halloween dispenser. So we'd set this ghost out in the yard, and it would fill it with candy, and we'd distribute it It would pass out candy when kids came up to it trick-or-treating. It could be operated remotely or it could be programmed. Not really sure. We're still working on that. So this is a concept sketch. This is an example of a design notebook. So where do we get into the orthographics? Well, here's an orthographic. We're looking at that object straight on. We've removed its costume, and we now see this assembly of all the pieces going together. And we're looking at it just from one view. I've got my head, various framing for the object, and it was all put together. And I've got annotations or notes all over it to tell me what it is. We're going to get into multi-view sketching. We start looking at the individual parts. For example, here is the part for the shoulder. Here's the shoulder of my robot, and I want to be able to load candy into one end, and I want the candy to come out the other end. I would need it to join to the main body of the robot. So I need a part. I need to make or buy a part to do that. Here's what I'm proposing to do that. A part that looks like this. You can see in my sketch that I'm showing it from a pictorial view here with some tonal shading to help you get the realistic look of what it is. You can see the opening at the top. It's going to be open through the bottom. It's hollow. You see what the object looks like from the top, what the object looks like from the front, and what the object looks like from the side. So here's my sketch of that T. Other components in the object, like this elbow, are going to use different types of drawings. Here's a sketch of that elbow, showing me what it looks like from one side and looks like from the other side. So we call this the front view and this is the side view. Notice that I've got them lined up so that everything matches in between the views. And I've added a special extra view called an auxiliary view to show what the top of that would look like straight on. Some of the parts we might need might be long. Like if I'm going to operate my robot 25 feet away by using a rope, I might want to describe the rope that I want to use. So I might describe the rope, which won't fit on this piece of paper, by showing its overall length, showing what it looks like in the sections, and then anything that's the same in the middle, I can cut out. So here's my two views, the end view, or left side view, and my front view. The dimension to say, hey, it's 25 feet long, and a break section taken out of the middle. We can use these techniques to help understand what our project will look like, things that we haven't designed yet, things that we're trying to figure out. Here, you can see views of the candy dispenser in process. I don't know completely what this will look like when it's finally done, but I know that I want to be dispensing a metered amount of candy through the pipe, so we're working through this process. So in closing, we can use different types of drawings to produce solutions to solve our technical problems. Multi-view drawings, as seen here, can help us understand and communicate our process so we can solve real-world problems or bring real-world solutions to real-world problems. Orthographic projection is a straight-on way of looking at things so that it looks true to measurement, showing one side at a time. We can use multi-views so that we can get an idea what objects look like from all sides. We draw as many views as we need to describe that object. And using this technique, we can come up with realistic, real-world objects to develop for our use for Earth's future.